It says a certain toaster has a heating element made of nichrome wire. When the toaster is first connected to 140 volts and the wire is at a room temperature of 20 degrees Celsius, the initial current was 1.7 amps. Now the current's going to decrease as the heating element warms up naturally because the resistance goes up, right? And it gives a final current at the final operating temperature. So one of the things we're going to need to know is we're going to need to know the temperature coefficient for nichrome. So that's something we can find in a table. So we just want to look up nichrome here. Alright. And instead of getting the resistivity this time, we want to look at the temperature coefficient. So we want this value right here. Alright, so our alpha for nichrome is 0.4 times 10 to the minus 3. So they gave us the voltage initially, which is 140 volts. They gave us the initial current, 1.7 amps. We'd really like to know what the initial resistance is, but we don't have it. So let's use Ohm's law to find it. So it's going to be delta V over I, which will be 140 volts over 1.7 amps. Looks like 82 ohms for this toaster. Alright, next, V final is going to be the same as before. New current is given, 1.53 amps. So we'd really like to find the new resistance, if possible. So what I'm going to do is I'm going to use the final voltage and the final current. Use Ohm's law. So 140 volts over 1.53 amps. 91.5 ohms. So it did go up as expected. Right? Now we should be able to plug in everything we have into the formula, and then that should allow us to solve for that final temperature. Let's try plugging in. 91.5 ohms is the final resistance, so it goes on the left. The initial resistance of 82.4 goes in for R sub 0. Plug in our coefficient that we found from the table. Then we'll leave our final temperature as a variable and plug in our initial temperature of 20 degrees. (91.5) equals 82.4. I'm getting 296 degrees Celsius. That'll do.